Good morning, friends. Today I welcome you all to online C class, and today our topic is linear search. In the last few classes, we have been discussing varieties of sorting techniques. Bubble sort we have discussed, selection sort we have discussed, insertion sort we have discussed, and we have finally discussed quick sort. So these are the four sorting techniques that we have discussed in the last few classes, and we have evaluated the performance of each of these sorting techniques. And now today we are going to look into completely a different concept called searching techniques. And in the searching techniques we are discussing linear search. And if you see the flow of today's lecture, it will be like this. Initially, we are going to discuss what are searching techniques, where they are used, and what are the different types of searching techniques available in the literature. And then we will look into especially linear search, how it is performed to search for a given element in a group of elements. Then after linear search is over, then our concentration is calculating the efficiency of this linear search. And once this is over, then we will proceed to developing the pseudocode for the linear search. Once pseudocode is ready, then we are going to write the C function code for linear search. Once this C function is ready, it is easy for us to develop a complete C program for linear search. And the last thing is, it is common assignment and important questions related to today's lecture. So let us start our discussion with the searching techniques. What do you mean by searching? How this searching is defined means there are a number of definitions available for searching. Searching, here I am giving one definition, that is, searching means it is the process of identifying the presence or existence of an element in a list of element or a group of element. So that is called searching. Means we need to identify whether a given element is there in a set of values or a group of values or not. Suppose if the given element is present in the set of values, then what we have to do is we have to tell whether that element is there or not in the list. Or sometimes what we will do is we will return the position where that element is found in a group of elements. If that group of elements are stored in a sequential memory locations, then we will return the position of that element for which we are searching, at what position in that group of elements it is present, whether it is present at the 10th position from the beginning of the list, or whether it is present at 15th position from the beginning of the list. So like that, sometimes we will simply tell whether it is there or not in the group of elements, and sometimes we will tell at what position that element is found. If that element is not there in the given group of elements, simply we will say that the element is not found in a given set of elements or given set of values. Like that we will tell. Now where we are going to use these searching techniques? Searching techniques are, it is one of the most widely used techniques. Because I will give one example to understand where these searching techniques are being used. Suppose university has announced your results, end semester results. Then what do? Immediately you will be logging into the university portal or university website, and then once you log in into the university website or web portal, then immediately it will ask you to, if you wanted to see your result, immediately it will ask you to enter your hall ticket number or your registration number. Once you enter your hall ticket number or registration number, and once you click on search or find button, then that hall ticket number value is taken and it will be searched in a list of results to see whether this hall ticket number is present in this list of hall ticket numbers or not. And all these list of values are stored in a university computer. Usually that computer we call it as a server or database server. Means a computer which maintains a database of the student results. So that is called a database server. So your hall ticket number will be searched in that list of hall ticket numbers which are available in the university server. And if this hall ticket number wherever it is found, immediately it will retrieves the information, result information related to your hall ticket number, and it will display that information on the screen. So that is how, means first we will search for that element. If that element is found in the group of elements, then we will grab or we will get all that information. Getting all that information from the database or taking all that information from the database, it is called a retrieval process. It is called retrieval process. And once the information is retrieved from the database, and then it is displayed on the screen so that user can see the result of his examination or her examination. So that is what we are using the searching techniques. Similarly, when you wanted to reserve a ticket online, bus ticket or railway ticket or movie ticket, so what do? Immediately you will give the option which theater you want to select the ticket. So that theater name you will enter, and it will searches the database in the computer. So the computer is storing the details of all the theaters available in that locality, and based on the theater name that you will enter, immediately it will show the list of options to you, whether you want to go for first show or second show or in the morning show or afternoon show. All that list of options it will show. Once you give your option, again it will searches whether in that particular show whether you are having vacancy to reserve your ticket or not. So everywhere like this searching process is being done. Everywhere searching is done. So searching is widely used in real-time applications to search for a particular record in a set of records. So each record contains some information, and each record is having some key value. So based on that key value, records are searched. And this key value is unique. Unique means each record is having a specific particular number, and that number will be assigned is associated with only that particular record. The same number will not be assigned to any other record in the set of records. So that is called unique value. So this unique value is called key value. So based on the key values, records will be searched. So therefore here I wrote second point as like this. It is widely used to identify a particular record in a list of records based on the key values. Every record is associated with a key value, and these key values are different for different records. Means there are no two records with the same key value. So it is a unique value. It is just like your hall ticket numbers. No two students will be having the same hall ticket number. So hall ticket numbers are different for different students. So therefore I can say that a hall ticket number is a unique value associated with the student. Means every student is identified by their hall ticket number, and hall ticket numbers are unique values. Like that, records are also associated with the key values, and the key values are unique. And if you want to search a set of records to identify whether a particular record is available or not, then you have to look into the key values associated with the records. But here in our searching techniques, we are not going to search for any records. Simply we are taking a set of values. We will search only that particular set of values. Means our scope is very limited. Really, when you are going and doing a job in a software company, multinational company, then you use these skill set which you are developing here to write the programs there for real-time applications. Here we are working with only a few set of values, and in that set of values we are going to search for a particular number. That is what written here. Here we consider searching for only a set of values but not a set of records. We are taking only set of values, not set of records. Searching can be done both on ordered lists and unordered lists. So what do you mean by ordered list and what do you mean by unordered list? A ordered list means it is the list in which all elements are arranged in a particular order, means sorted order. Means the elements will be arranged either in the ascending order or descending order. So then that list is called ordered list. Searching a ordered list is very easy. Means when you wanted to search for a particular value in a ordered list, it is very easy. I will give you one example. When your results are displayed on the notice board, usually results are displayed in the increasing number of hall ticket numbers, in the increasing order of hall ticket number. Suppose if you wanted to search for a particular student who is having roll number 100, so then we can go on searching because roll number 1, 2, 3, 4, 5, 6 like that we can go on down in the list until we come across a number 98, 99, 100. After 99 we know that 100 result will be there in the next line, and once 100 is over then 101, 102, 103 means suppose if the 200 students details are displayed who are having roll numbers from 1 to 200 and you are searching the list for a student who is having roll number 100, then what do? You know directly where that is located. 1, 2, 3, 4, 5, 6 like that you are going down in the list till you come across 98, 99, 100. There you will stop and you are not going still down in the list. That is 101, 102, 103. You don't require the results of those students because you need to find out the student who is having hall ticket number 100. So at that row you will stop. Means once you come across your desired element or desired record, there you are stopping the searching process, isn't it? And since all the student results are kept in the increasing order of hall ticket numbers, it is very easy to you to find out a given value. Suppose assume that these results are not arranged in the increasing order of the hall ticket number. Zigzagly assume that the results are displayed in a zigzag manner of the hall ticket numbers. Means first you are having the first row the student who is having roll number 53 is displayed. In the next row the student who is having hall ticket number 98 is displayed, and in the third row the student who is having roll number suppose say 20 is displayed. So then if you wanted to find out the result of a student who is having roll number 100, then what you have to do? You have to go through each roll number on each line till you come across 100, and you do not know where that student result possessing hall ticket number 100 is there, at what line it is found, we are not sure. So it is a difficult process, and so such list is called unordered list. In an unordered list, elements are not in a particular order, means the elements are not in the sorted order. So searching techniques can be used both on the sorted lists and unsorted lists. And there are some types of searching techniques. They can be used only on sorted numbers, sorted lists. They cannot be used on unsorted lists. Okay, we are going to see. And usually these searching techniques based on the location where you are storing these elements which are to be searched, the group of elements which are to be searched based on the location in the computer where you are storing these numbers, group of values which are to be searched based on the location of their storage, they have divided into two types. Searching techniques are divided into two types based on the location where the group of elements are stored. So what are these two types of searching techniques? Internal searching techniques, external searching techniques. And this is not known to many people. Internal searching techniques means in the internal searching techniques, the group of elements which are to be searched, all these elements are stored in the computer main memory. So therefore, because of this reason, they are called internal searching techniques. External searching technique means the group of elements which are to be searched, some of them are stored in the main memory means RAM memory of the computer, and some numbers are stored in the secondary memory means hard disk. So to search for a particular record where the records are scattered over main memory and some of them are scattered over hard disk, then if you are using any searching technique to search for a group of elements which are scattered in the main memory and hard disk, and that type of searching techniques are called external searching techniques. Here our scope is limited to only internal searching techniques, means here the group of numbers which we are going to search, all this group of numbers we are assuming that they are stored in the computer main memory. Main memory means RAM. So our discussion is limited only to internal searching techniques, like in sorting techniques. Sorting techniques also we have two types of sorting techniques: internal sorts and external sorts. Internal sorts means the group of numbers which are to be sorted, all that group of numbers or values are stored in the computer main memory. External sorting techniques means these are the techniques used to keep the elements in the order where the group of elements are scattered in the main memory and some members are there in the secondary memory. Okay, so that is called external sorting techniques. So here our discussion is limited to internal searching techniques. Means here we are assuming that the set of values or group of values which are to be searched, all these group of values or set of values, we are assuming that they are stored in the computer main memory. Main memory means RAM memory. Now, how many types of searching techniques are available? We have different types of searching techniques, and these searching techniques are classified into two types: linear searching technique and binary searching techniques. Linear searching techniques and binary searching techniques. The name itself indicating what is linear search and what is binary search. So first we will start with the linear search, and then in the next class we are going to discuss about binary searching technique. So first let us see about linear search. Linear search can be applied on the ordered list and also on unordered list. It can be used on both the lists. So here we are going to consider how this linear search is used on the unordered list. Same concept with a little modification you can apply on a unordered list. We are going to discuss how linear search is used on unordered list. Same technique with a little modification you can apply on the ordered list. Okay. Now see, it takes a key value. In a linear search, we will take a key value and the group of elements, list of elements from the user. Means from the user, we will take a key value. Key value means the element for which we have to search. And a group of elements means list of elements also we will take from the user. And what we will do is, we will search for this key value in the group of elements to see whether this group of elements are containing this key value or not. Suppose if the element key value is found in the group of elements, means in the list, then we will try to return the position in the list where that key value is found in the group of values or list of values, or simply a list. At what position it is found. So that position we are going to return if the element is present in the list. Suppose if the element is not present in the list, means the group of elements are not having the key value for which we are searching. In that case, simply we will return a -1 to tell that the element is not there. It is not available in the group of or list of elements. See, what is the logic of linear search? Linear search logic is very simple. We will take a key value from the user, and we are also taking from the user a list of values. Then we will compare key value against each value in the list. Okay, so right from the first element in the list to the last element, we are going on comparing key value with every element in the list, starting from the first element till the last element. Up to what we will proceed in the list. So we will go on searching for the key value in the given list of element, starting with the first element. And this process goes on until we come across a element. Means the key value is found in the list, or we reach the end of the list. This process will be terminated. The searching process is stopped only when we find the element in the list. Then we will stop the searching process and return its position, at what position it is found, or till we reach the end of the list. Till we reach the end of the list, we go on searching. If the element is this possible, we will reach the end of the list. If the element is not there in the list, then only we will reach the end of the list. If the list contains the element, then somewhere in the middle or beyond a little middle and or just before the middle element, so we will get the element. Okay, so this is the procedure. Means we are taking a key value. For that key value, we are searching the list of elements right from the first element. Key value is compared against each element in the list right from the beginning. And this comparison process goes on till we come across a key value in the list or till we reach the end of the list. Then only we will stop the searching process. If the element is found, then we will return its position. If the element is not found, simply we return -1. So this can be explained using the mathematics like this. So before going to see the procedure using mathematics, let us take few assumptions like in sorting techniques. Here the first assumption is we are taking an array X, and this array X is used for storing n elements. Means a group of n elements we will store in the array X. And we are assuming that all these elements are there in the array X from the index position 0 to n-1, because n elements we are storing. If you start storing these elements from index 0, the last element will occupy index position n-1 in the array X. Then we are also assuming that all these elements are not in the sorted order. Means it is an unordered list. And the same procedure you can also apply whatever technique we are going to discuss on unordered list. Same technique can also be directly applied on the ordered list. If you can modify little bit this method, then you will get more efficiency on a ordered list. Now we will take a variable key, be the variable that contains the value for which the array X is to be searched. Means a key is a variable which contains a value, and for that value we are searching the array X. It takes one pass through the elements of the X. Pass means, you know, already in the searching techniques we have, sorting techniques we have discussed what is a pass. A pass means moving from the first element of the list to the last element of the list. It is called pass. Here, to search for a key value in the given list, we are taking only one pass. In the pass, what we are doing at each element, the key value is compared with every element in the list to see that whether this key value is equal to that element or not. So that is what we are doing. Means here key is compared against every element of the array X, that is X of I, where I is changing from 0 to n-1, because in the array you are having elements from 0 to n-1. So these are the assumptions. Now what is the procedure for linear search? The name itself representing that, a linear search. Linear search means we are going on in a sequential order to search for the element in the list. Sequential order means we are starting with the first element and the key value is compared with the first element, and then if it is not matching, key value is not matching with the first element, then we are going to the second element, and there second element value is compared against the key value. If the key value and second element value is not matching, then we are jumping to the third element, and there again key value is compared against the third element value. So like that we are proceeding. So this way of going from one element to the next immediate element in the list is called linear movement. Since In this linear movement, we are searching for an element, key element. So therefore it is called a linear search. And since this list is unordered list, so therefore we can say that we are performing a linear search on an unordered array or unordered list. So what is the procedure? The procedure is very simple. At each element of the array, means at x of I, where I value is changing from 0 to n minus 1, the key value is compared against x of I. If key value, if it is equal to x of I, then we will stop the searching process and we will return I value. I value means the position, index position, where that element is found. Suppose if the key value is not equal to x of I, then what we will do, and I value is not reached to the n minus 1, then we will increment the I value and we will repeat step 2 and 3. Okay, until either the element is found or we will reach the end of the list. When I reaches n minus 1, yes, and I value goes beyond n minus 1, means I value becomes n, then we know that I value can go beyond this list only when the element is not found in the list. In that case, we return value minus 1. If anywhere element is found, immediately we are stopping the searching process. There we are going to return the index value, at what index value in the array that element is found. That we are going to return. So this is the simple procedure. Let us explain with a set of integer values. Here I have taken the same set of values which we have worked for sorting techniques. So these are the set of elements that we have used in the different types of sorting techniques. So here n value is 8, means we have taken 8 integer values, and all these 8 integer values, initially we are storing them in the array x from index position 0 through index position 7. So means the last element is kept at the index position 7. Now we have to search this array for an key element. Key value is 86. We have to search this list to find out whether this key value is 86, whether that key value is present in the list or not. So how it is done? First, initially I value becomes 0. I is a loop control variable which keep track of the index positions in the array. So initially we are assuming that because the first element of the list starts at index value 0, so therefore we are assuming that initially I value is 0. When I value equal to 0, x of 0 element is compared, x of 0 value is compared. X of 0 means first element, 25. We will check whether 25 is equal to the key value is 86. 25, whether it is equal to 86, no. So then we are incrementing the I value becomes 1. I value becomes 1 means x of 1 is compared. X of 1 value is 57. So we will check whether x of 1 value is equal to key value or not. X of 1 value is now 57. 57 is equal to 86? No. So therefore I value we are incrementing. Previously I value is 1, now it becomes 2. So 2 means it find out the next element in the list, x of 2. X of 2 value is now 48. 48 whether it is equal to 86? No. So again we are incrementing I value. I value becomes 3. When I value equal to 3, x of 3, x of I means I value is 3. X of 3 is compared. So 37 whether it is equal to 86? No. So therefore we are incrementing I value. I value becomes 4. And then I value is 4 means x of 4 is compared against key value. X of 4 value is 94. 94 whether it is equal to 86? No. Then I value is incremented. Means if they are not equal, we are incrementing the I value and we are going with the next element in the list. I value becomes 5. I value becomes 5 means x of 5. X of 5 value is 33. 33 whether it is equal to 86? No. So increment I value. I value becomes 6. I value 6 means x of 6 element. X of 6 element is 86. Whether 86 is equal to 86? Yes. So therefore you stop the searching process there because you have come across the key value. Key value is 86 and the element value at x of 6 position also. Index position 6 in the array you are having 86. Means key value is matching with this element. So immediately we will return I value. I value is 6. Means at index position 6 in the list you have key value. Key value is 86. That is found at index position 6 in the list. Or if you wanted to say in normal terms, what is the position of 86? Element 86 in the list. So normally positions we will compare in general usage from first element means position 1, position 2, position 3, position 4, position 5, position 6, position 7 means I value is 6. 6 means for that you can add 1 because we have taken I value from 0. So in general terms we will discuss the position as 7. 86 is there in the list at which position? 7th position. Like that we will say. To the I value you can add a value 1 and you can tell that it is found at the position I plus 1. So like that you can tell. This is how. So if the element is there, then we will starting comparison. We are starting the comparison process with the first element. If that is not matched with the key value, then we are going with the next element. If that is not matching, again we are going with the subsequent element till we come across an element. Now we will take a different case where the element for which we are searching is not there in the list. Suppose I have taken same set of values I have taken, but key value I have changed. Key value I have taken it as 50. But here the list contains nowhere 50. So how the selection process is, how the searching is done? Again, we will start with I value 0. I value 0 means first element. We will compare first element with the key value. 25 whether it is equal to 50? No. I value is incremented. It becomes 1. Becomes 1 means x of 1. X of 1 is 57. Compared against key value. 57 whether it is equal to 50? No. So I value is incremented. Again, it becomes 2. Then I value is 2 means x of 2 element. X of 2 element is 48. 48 whether it is equal to 50? No. So increment I value. I value is 3. I value is 3 means x of I. X of I. X of I means I value is 3. X of 3. X of 3 means 37. 37 whether it is equal to 50? No. Go with the next element by increasing the I value. So next element is 94. 94 whether it is equal to 50? No. Increment I value. I value becomes 5. X of 5 is 33. Compare 33 against key. No, it is 33 is not equal to 50. Again increment I value. I value becomes 6. I value is 6 means x of 6. X of 6 value is 86. 86 whether it is equal to key value? No. So increment I value. I value becomes 7. X of 7, 12. 12 whether it is equal to 50? No. You increment I value. But I value if you increment it becomes 8. But x of 8 element is not there. The last boundary for the list is n minus 1 for n elements. So I value has been reached n minus 1. So with n minus 1 also it is not matching. X of n minus 1 also it is not matching. Means simply return minus 1. In the previous case it is found at a location, index location 6, we are returning 6. Here element is not found. All elements have been, with all elements key values compared, a list is over, but nowhere match is found. In that case we will return minus 1. So when the minus 1 is returned by the search, linear search means we assume that the element is not found in the list. This is how you have to explain. This is case 2. In case 1 element is there. In case 2 we have selected a key value such that it is not there in the list. In that case we have to compare key value with all the elements. If n elements are there, n comparisons are required if the element is not there in the list. And sometimes the element for which we are also searching is found in the last position of the list. In that case also we need to perform n comparisons. And sometimes what happens is the element for which we are searching, it is present in the first position itself. In that case with one comparison itself you can find the element because it is there in the first position. That is how you can do with the linear search. Now, what is the efficiency of the linear search? Here, we will evaluate the efficiency of linear search by taking 3 cases. Best case, worst case, average case. Best case means it is the case where the element is found in the first position itself. When the element is there in the first position itself, key value is compared with first element, you come to know that the element is there in the first position. Key value is matching with the first element. It means element is there in the first position. Means for that only one comparison is required, and after finding the elements, we will stop the searching process. Means only one comparison is done. So therefore time complexity in the best case is order of 1 for the linear search. Worst case means we here two situations are there which are contributing to the worst case. One is when the element is not there in the list. That is one possibility. And another one is sometimes element is there in the last position. The key value is found in the last position. Then we need to compare key value with all the elements, right from first element to the last element. When you perform the last comparison, means nth comparison, then only you are coming to know that element is there in the last position. And other possibility is if the element is not there in the list, key value is not there in the list. In that case also, key value should be compared against all the elements of the list. And after comparing with the last element, even then if it is not matching with the key value, then we can conclude that the key value is not there in the list. Okay, so this will means both possibilities. One possibility is the key value is not there in the list, and another possibility is the key value is there at the last position in the list. In these two cases are contributing to the worst case situation, where the number of comparisons are required is n. So when n comparisons are required, the time complexity is made as order of n, because you are performing n comparisons in the worst case. Then average case. Average case is nothing but the element is found somewhere in between first element and the last element positions. Assume that it is found exactly in the middle of the list. Middle of the list means n minus 1 by 2 position. For that, how many comparisons are required? N by 2 comparison. Because we are assuming that element is there in the middle of the list. If 8 elements are there, if the element is found at 4th position or 5th position, almost it is in the middle of the list. In that case, we need n by 2, approximately n by 2 comparisons. So it is an equation in the form of n terms. So therefore, time complexity is order of n. Means the average case and the worst case, the time complexity is order of n. In the best case, linear search time complexity is order of 1. Then what about its space complexity? Space complexity is nothing but the space occupied by the elements in the linear search. So here we are taking a group of n values, and that group of n values we are storing in the array x. For that, we are using array x for storing n elements. Assume that you are working with integer on a 16-bit machine. A 16-bit machine will uses 2 bytes of space for storing each integer. If you wanted to store n integers, you require 2 into n bytes of space. And in the process, if you are using the space for any additional variables, that can also be specified as a part of space complexity. 2n bytes are required for storing n group of elements. If any other additional variables are used, the space required for that additional variables also you can include in the space complexity. So space complexity finally 2n bytes plus space required for additional variables, if any one of them, if they are used in the program. Now let us see how to write the pseudocode for the linear search. It is very simple. So we are naming the procedure as linear search, and it is taking 3 arguments. One is the array where the elements are stored. N is another variable. N will represent how many elements are available in the array X. And third variable is key variable. Key variable contains a value for which this array is to be searched to see whether this key value is available in the list or not. If the key value is found, we will return the index position where that element is found. If key value is not available in the array X, then we will return a minus 1. So we are using a loop control variable I. It is declared as integer, and I value is changing from 0 to last element position is n minus 1. I is changing from 0 to n minus 1. Initially I value is 0. When I value is 0, it will compare x of 0. I value is 0. X of 0 means first element is compared against key value. If both are equal, and immediately we will return I value, means 0 value, index 0 value. If key value is not equal to x of I, then I value becomes 1, and it will compare again x of with x of 1. X of 1 means the second element, to see whether second element value is equal to key value or not. If it is not equal, again I value is incremented, becomes 2, and it compares x of 2 means third element with the key value. If it is both are matching, then it returns I value. Otherwise, if they are not matching, then I value be incremented by 1 means I value becomes 3. then with x of 3 means fourth element in the list, it compares the key value. If match is found, then it returns I value, otherwise I value is incremented. Like that, I value goes on incremented up to n minus 1. Finally, the comparison is made with the last element. Okay, so this process, this loop will be stopped if the element is found at any place. And if the element is not found at any place, I value becomes n. I value goes beyond the list. Okay, and then we are returning minus 1. Okay, so this is how the simple L search. L search means linear search. Linear search means searching in the elements in the sequential order, starting from the first element. And if that is no match is found, key value is not matching with the first element, we are comparing with the second element. If second element is not matching, then we are comparing with the third element. Means in a sequential order we are proceeding. So therefore it is called sequential search, or it is also called linear search, because in a linear fashion we are moving. So that is how it is done. Next, once pseudocode is ready, you can write the algorithm for linear search. So algorithm is nothing but a sequence of steps written using English sentences or English phrases. So in the pseudocode we have written the statements. Each statement you can convert it into equivalent English statement or English phrases, English sentences or English phrases. Then it becomes an algorithm. So it is writing an algorithm is easy because you are asked to write only English statements in the place of these pseudocode statements. So you can write in your own words. Means developing an algorithm for linear search is left as an exercise to you. Now, once the pseudocode is ready, it is the time for us to develop a C function code for linear search. What is the C function code for linear search? Very simple. Same. We are using a function called linear search, and it returns integer value to the calling function. Then it is expected to receive 3 arguments from the calling function. First argument is array, which stores the values, and n. Second argument is variable n. So n represents the number of elements available in the array x, and third argument is key value. So key variable contains the value for which these array elements are to be searched. So inside the L search, we are using a variable I. We have declared a variable I. So I is keeping track of the index positions of the elements in the array. So I is value starting from 0. 0 index value 0 means first element. When I value equal to 0, I is going to change from 0 to up to n minus 1. So when I equal to 0 at each value of I, we are comparing each element in the array against key value. If any element in the array x, if it is matching with the key value, there itself we are stopping and we are returning I value. I value means index value. At what index value that key value is found in the array x, that index value we are returning to the calling function. If the element is not matching with the key value, simply we are continuing with the next I value. This process repeats on until we come across an element or we will reach the end of the array. So when I value becomes n, after n minus 1, I value becomes automatically incremented by 1, means from n minus 1 it will go to n. When I value equal to n, n is less than or equal to n minus 1 becomes false. Then loop is stopped. Then it returns minus 1. So I value is going up to n means the element is not found in the list. So therefore we are returning minus 1. If I value is less than n means when I value is less than n minus 1, there itself it is stopped, means somewhere element is found. So therefore we are returning the index value of that element. Okay, this is how the function is implemented. So once this function is ready, so it is easy for us to write a complete C program for linear search. So here is the program. So program on linear search. So it is using unordered list. Same program you can use, same technique you can use even for ordered list. But since elements are in the order, sorted order in the ordered list, so it is easy to perform a searching there. Okay. Integer linear search we have declared here. So it is expected to receive 3 arguments from the calling function, array name and number of elements in the array and the key element for which this array is to be searched. And inside the main program we are declaring an array X with a storage capacity of 20 integers it can store, and n is we are using to represent the number of values in the array X. Key is used to store the value for which we need to search. I is declared to keep track of the index numbers in the array X. Okay, R is used to store the return value of the LSearch function. LSearch function may return the index position where that element is found, or it may return -1 if the element is not found. So first we will ask the user to know how many integer values are there with the user. That value we are reading and storing in variable n. User may enter n value as 5 or 10 or 15 or 18 like that. If n value is 5 means the user is having 5 integer values to search for. Okay, so we are asking the user to enter all integer values in a row, and we are instructing the computer to read all that integer values one by one and store them inside the array X starting from the index position 0 up to index position n-1. So this statement instructs the computer to read the integer values given by the user one by one and store them inside the array X. Then we are asking the user to enter a key value. Okay, so scanf %d, so that value given by the user we are storing in the variable key. Means whatever value is there in the variable key, for that value we have to search the array X to see that whether this key value is there inside the array X or not. So first we are printing the given set of values from 0 to n-1, whatever is stored in the array. First we are printing that values given by the user on the screen. Then we are making a call to LSearch function by passing this array as an argument and then number of elements in the array, and for which we have to search that array, that key value also we are passing. Then LSearch function may return the index position if the element is found, or it may return -1. That value is stored in the variable R. So once you are making a call to LSearch function, the main program will be stopped here, means it is suspended temporarily for its execution, and control is transferred from main program to the LSearch function. LSearch function is written here, definition of the LSearch function. Whatever we have discussed, the LSearch function, C code for LSearch, same C code I wrote here. Means if the element is found in the list, it returns the index position where that element is found in the array X. Otherwise, if the element is not there in the array X, then it returns -1. So whatever value it is being returning, once that LSearch function execution is over, it returns some value. That value is stored in the variable R. Here we are checking whether variable R value is equal to -1 or not. Means if the LSearch function returns a -1 to the R variable, so it is assumed that the element is not found in the list. Means the given list doesn't contain the key value. If the element value is if the value returned by the LSearch function is not -1, then definitely we know that that element is present, key element is present in the given list. So here we are printing the message, the %d means at this %d key value is printed. So means the given key value is found at %d position. At what position? R+1 position it is found in the list. So that is what we are displaying. Then program is over. Okay. So this is how you can write this C code very easily. This is the definition of search function. So LSearch is very simple. In the list we are going on comparing the given list of elements one by one, and that searching process will be stopped when we come across the key value in the list, or we will reach the end of the list. Then only searching process is stopped. Okay. Now what are the important assignment questions? Explain linear search with a suitable example. For this question, what you have to write is, you have to write what is linear search. What is linear search? That little information about the linear search, and then logic of the linear search, then assumptions in the linear search, how you are proceeding, then the procedure, how the searching is performed, Then you have to explain with an example by taking a set of values and a key value as an example. Here in the case 1, you select a key value as an element which is there in the list, and in the second case you select a key value which is not there in the list, and you explain in both cases how the searching is being done. Okay, so that is what you have to write for this question. And then next question is, write the pseudocode and algorithm for linear search. Pseudocode is given to you, and you have to convert those pseudocode statements into algorithmic statements by writing them in the English sentences or English phrases. So that is algorithm is left as an exercise to you. Using pseudocode statements, you convert them into algorithmic statements. And then write a C program for linear search. C program is given to you, and the same C program you write and explain it in the examination. Okay, so these assignment questions you write and submit it to me within 2 days. Okay, in the next class also I am going to give assignment related to the binary search. Okay, so linear search assignment and binary search assignment, you consider it as assignment 9, and you have to submit that within 2 days. Means by Thursday you have to submit. Today's class and tomorrow's class assignment questions, you have to write it, and then you have to submit it by Thursday 1 p.m. And we are going to meet in the tomorrow's class. In tomorrow's class we are going to discuss binary search technique. Okay, so in this lecture, if you are having any doubts, you can call me on my personal mobile number 9848919656. Okay, and thank you all for your patience listening. Thank you all.